Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with the same module, that is procedural programming module. In the last class we have started with chapter number 16, that is C under Windows, that is how to use the C language using Windows. Till now we have studied about how to use the C language using various tools, using various applications, that is a user friendly. Now it's a time to use the C under the Windows, that is what is the dissimilarity or what are the similarities that is available with the C language, that when we use C language with the Windows or under the Windows. So in the last class we have started with this one. We have covered only 2 or 3 topics, that is what is a window and which window is used for the C language. Then we have discussed what is the integer, what is the difference between this and that is what we have learned in the C language earlier. What is the difference between the C language in Windows, and what is the difference between C language in Linux or Unix. So we have studied about this one, that is how we can use the C language or how we can use the C under the Windows, right? So let's take a quick review what we have covered in the last class, then move to the next part, that is today's topic. So this is just a theoretical topic, we have to study the theory. So this is which windows, then integers, then use of the type def, then how we can use the pointers in the 32-bit world, then what is the memory management, what is the device access. So we have covered what is a Windows or which Windows, what is a pointer, what is a integer, what is a type def. So we have covered 2-3 topics in the last class. Today I'm going to start with the next topic, that is the memory management. So let's take a review what we have covered in the last class. In the last class we have studied about what is the background, that is why we are using the Windows, what is C language, what is the main concept of C language, who generates the C language, what is the main motto of using the C language. So this says, so far we have learned every single keyword, operator, instruction that is available in C. Therefore we are thorough with the language element that we were there to learn, that is we are thorough about the languages that is available in the C language. So it may be 16-bit compiler, it may be a 32-bit compiler, but there is a difference. We have till now we have covered about the 16-bit compilers. Now there is a time to change, that becomes the 32-bit platform, because it is generally used by all the commercial organization, everyone. Why? Because 32 takes the more bits as compared to the 16-bit. The operation is same, everything is same, but the capacity is huge, that is a 16 to 32, that is means a double capacity. So that 32-bit provides many features that are that is available in C language for the beginner as well as the experience holders. So we have studied about this in this paragraph. Then C fundamental are out of the way and you are confident about the language features. It is a time for us to delve in the modern 32-bit operating environment. In today's commercial world, 16-bit operating environments like DOS are more or less dead. That is, we have not used DOS in nowadays, because we are using the Windows, we are using the GUI, that is a Linux. So there are multiple operating systems which have come in the market in place of this one. Hello, hello. Yeah, are you able to hear me? Okay. Till now you have not heard anything. So this is the next. Then we have studied about the what is the C fundamental that is used in the 32-bit environment. That is how we are using the 32-bit environment, or how we are using the software with the 32-bit environment like Windows and Linux. In this chapter we would explore how C programming is done under the Windows. That is how we are doing the C language, how we are doing the C programming in this language, in this Windows. That is another concept. Then we have studied about this one, that is how to use the C language with a fundamental concept. Now next question arises, which windows, that is which window is used over here. There are multiple windows. That means there are multiple versions of the Windows, like for example Windows 95, 98, NT, ME 2000, XP, Server 2003. They are much like a same, their appearance is same, everything is same, but their functionality is different, their interface is little bit different, but everything is same. That is, functionality is same, but the outer look, that is the feel and look, is totally different. Then architecturally they are huge different among them, so but they are look like same, because the Windows is same, 7 version is same, XP is same. So there are so many differences that makes the, or that Microsoft categorize the different version under two categories. What are the two categories? One is consumer Windows, one is Windows NT family. So these are the two concepts that is used in Windows. So these are means these are the divisions of the Windows. One is consumer Windows and one is Windows NT family. Then we have studied about window NT family, how we are using that, or what are the components, what are the categories of window that lies in the consumer window, and what are the categories that lies under the window NT family. So consumer windows are targeted towards the home or small offices like Windows 95, 98, ME. That is a part of the consumer window, and that is generally used for the home. That is for personal thing, for small offices. But where the topic comes to the multiple users or the big offices, then only and only this one, that is the window NT family, works. Then we have studied about integers, that is how to use the integers in the Windows, that is how to use the integers in the 16-bit environment and 32-bit environment. The main difference is that in 16-bit, the size of the integer, that is integer takes 2 bytes in the memory, that is the size of the integer is of 2 bytes, as against it, that is while in 32-bit operating system or in 32-bit environment, an integer is of 4 types, that is the requirement of the integer or the capacity of the integer is 4 bytes, and their range is also different in the 32-bit environment and 16-bit environment. But therefore there is no difference between the int and the long int. But if we wish to store the age of a person in an integer, it would be improper to sacrifice a 4-byte integer. That is, it would be not subtle, it would not be not advantageous for us to use the age of the person or to store the age of a person in an integer. Right. In such a case, it would be more sensible to use a short int since it only used, or it is only 2 bytes long. That is, whenever we use the 32-bit environment, it is mandatory that integer takes 4 bytes. But if I want to use the or store the value of a age, then why should I waste 4 bytes? So either we can use the 16-bit environment, or either we can use the short int that is of only 2 bytes. Then we have studied about what is the use of type def in 32-bit environment. This is the use, that is color reference is the name and color is the type def, that is the name that is used, that is defined for this one. So whenever I use color, that means color reference. H, that means handle. W, that means W param. L, that is L param. B means bool, that is a boolean algebra. Therefore, a typical C under Windows program would contain several such type def. That is, there are so many type def, or there are two categories of type def that is available in any C programming that is available under the Windows. The first one is, a typical Windows program is required to perform several complex tasks. That is, a typical means major Windows program is required to perform several complex tasks. For example, a program may print documents, send emails, perform the file input output, manage multiple threads, draw in a window, play sound music, and there are multiple operations that is done by using the program that performs input as well as the output. Next reason is that why there is a usage of type def, because there are so many places where we want to gather and work with dissimilar data, that are data that is not related. So in such a case we are also required the type def in the 32-bit operating system. This is an example how to use the type def. First of all, a structure is defined that contains top, left, right, bottom. Structure is closed. Then uses the type def. That means the struct rect is converted into or is given a new name, that is a capital RECT, that is a rect. In the same way, type def struct rect pointer, that is given a name, that is a prect, that is a pointer rect. Then declaring the variables of the rect, that is your new name, now uses the RECT, PRECT, PR, that is R and PR are the variables of the pointer as well as the normal variable. What have we achieved out of this? That is what we have achieved. It makes the user defined data type like structure look, act or behave similar to the standard data type like integer, float. You may agree with that the following declaration. What is the declaration? That is rectar int I are more logical than the struct rect r int I. That is, if I define type def, it is more beneficial for us to divide the data, to store the data, to make the data, that is to initialize the data or to initialize the variable that is of rect type. This is the condition that we have discussed. This is the condition that is used for type def. Now, then we have studied about how to use the pointers in 32-bit world. That is, how to use the pointer. What is the difference between 16-bit pointer and the 32-bit pointers? So this says in 16-bit we would run only one application at a time, but if I am using the 32-bit, there are multiple applications we are using, or there are multiple applications we are approaching at the same time. As only one program could run at a time, this environment was known as the single tasking environment. Which environment? That is your pointer. Since only one program could run at a given time, entire resources of the machine like memory, devices are accessible to the program. That is, there is only one device, there is only one management, everything is under the hand of the one. But in under Windows 32-bit environment like Windows, several programs resides and work in the memory at the same time. Hence, it is known as multitasking environment. That is your Windows, or that is your 32-bit operating system. In client, there are so many program, or Windows takes so many program, resides in the so many program, so it is used, or it is also known as the multitasking operating system. Now, this is the concept how it will be used. Now there is a next concept, that is the today's topic, that is your memory management. So let's start with the today's topic, that is your memory management, how memory management is done, and what is the relationship between the memory management and the device access. So this is memory management. This says, since users have become more demanding, modern day applications have to contend with these demands and provide special or several features in them. That is, most users have become more demanding. That is, day by day, the user requirements are not ending up, but they are increasing on the day by day. Modern day applications like Word, Excel, PowerPoint, 13 or 10 or 14, maybe any version, have to contend with these demands and provide special or several features in them. Suppose there is no projector in my room, so that provides a projector, TV and so on, whatever required in the classroom, that will be okay, and that will be provided to the multiple persons. That is, since users have become more demanding, modern day applications have to contend with these demands and provide several features in them. That is, they have to use the various, they have to contend with these demands and provides various features that is available in the C language. That is, there is so many requirements that is available for the memory. To add to this, under Windows, several such applications run in memory simultaneously. That is, more than one task are running at the same time under the memory management, or that is provided by the memory management. The maximum allowable memory is 1 GB, and that was used in 16-bit environment. This is a 1 MB, sorry, not GB, this is 1 MB, and that was just too small for this. Therefore, Windows have to involve a new memory management model. That is, Windows have taken the new management memory model that is used. New memory management model that is used, that is that Windows runs on the next program. Windows run on the 32-bit microprocessor. Each CPU register is a 32-bit ROM. That is, every CPU register that is available is of 32-bit long. That is the main reason, that is the main difference between this one and this one. This says, since Windows run on 32-bit microprocessor, each CPU register is 32-bit long. Whenever we store a value at a memory location, the address of this memory location have to be stored in the, or has to be stored in the CPU register at some point of time. That is, we have to store the data of the CPU register, or we have to store the data into the CPU register at some point of time. Therefore, a 32-bit address can be stored in this registers or in these registers. So whenever we use this one, so whenever we have to store the value in a memory location, the address of location have to be stored in the CPU register at some point of time. Therefore, a 32-bit register can also be stored in the one register or in these registers. This means that we can store 2 power 32-bit unique addresses in the registers at different times. That is, we have to store, or we can store 2 power 32-bit unique addresses in the registers at different times. As a result, we can access 4 GB of memory locations using 32-bit register. So the main concern is that, main crux is that there are two types. One is 16-bit, that is the older one. New one is your 32-bit. The data will be stored of the new registers, or 32-bit register that will be stored in the CPU registers. However, if you decide to install 4 GB memory, it would cost a lot. That is, whenever we need the 4 GB memory, that is a lot of, or that needs a cost of load to set up all these memories. Right? Hence, Windows uses a memory model which makes use of the much of the physical memory as or as has been installed, and simulate the balance amount of memory on the hard disk. Be aware that this balanced memory is simulated as and when the need to do arises. Therefore, memory management is demanded based. That is, memory management in simple terms means managing the memory. That is, whenever we have to manage the memory, that can be done by using the memory management. So we can use the memory, we can divide the memory. That is, suppose my requirement is now that CPU needs the memory, that can be handled by giving them suitability. That is, if I need the memory, that means there is a requirement of the memory. If I don't need, that means the requirement is not increased. Yeah, everyone, my voice is not audible to you. Yeah, hello. Okay, but Larry, problem is that this is audible, but not up to the mark. That's the okay. Just a minute, I will try. You tell me. Uh, just a minute. Now it's okay. Hello, hello, hello. Okay, okay, okay. So, in case of different memories, different capacities, different locations, there is a balance amount. So, all these dissimilarities or all these provisions can be handled by the memory management. That is, memory management is the demand-based memory. That is, whenever there is a demand of the memory, we can use the memory. Whenever there is no demand of the memory, there is no need of the memory. That is done by the memory management. Note that programs cannot execute straight away from the hard disk. That is, program is not executing directly from the hard disk, but they are using the physical memory or they are stored in the physical memory before they are or they get executed. Now, suppose there are multiple programs that are already in memory and a new program start executing. If this new program needs more memory than what is available right now, then some of the existing program would be transferred to the disk in order to free the physical memory to accommodate the new program. That means suppose I'm or my CPU or my processor is executing one program. Suddenly a new program arrives and that new program requires a lot of memory. So now what is the concern? Either I can uh, transfer the old one that is already in running or either I can take out this new program this that is currently in running. So all this done is done by the memory management. So this says if the new program needs more memory than what is available right now, then some of the existing program would be transferred to the disk in order to free the physical memory to accommodate the new program. That is the already available or that is existing program that is already executed, so that will be bent to the or that will be transferred to the disk in order to free the physical memory to accommodate the new program. This operation is often known as page out operation. So this is the operation that is done or that is known as the page out operation. Here page stands for a block of memory. That is, page means a combination or a block of memory that is a usually of 4096 bytes. So when that part of the program that were paged out is needed, it is brought back into the memory, that is the page in operation. So this means whenever there is no need, we have to, or whenever there is a high need, we have to page out the memory that is transferred to the disk, and whenever there is no, that means there is no burden, there is no capacity that we can page in the program. So one is page out, one is page in. This keeps on happening without a common user knowledge all the times while working with Windows. So this happens, but you do not know why. Because this happens internally. You are not able to see all these views. That all these views can be done by the memory management under Windows. Now, some of the important facts that you note about the paging. Paging means transferring the page or moving the page from one part to the another and another part to the first one. Now, what are the facts? The first point says part of the program that is currently executing might also be paged out to the disk. What is a fact? That is a more fact or that is a few facts that is also available. That is the part of the program. Suppose I am executing one program, that is that program or that part of the program that is currently executing might also be paged out. That is also transferred to the disk so that the capacity is available and the data will be stored efficiently and effectively. The next point says when the program is paged in, that is when a program is coming from the disk into the memory, there is no guarantee that it would be brought back to the same physical location where it was before it was paged out. That is, there is no location that is fixed. When we move out from this or when we transfer the page, that means that location is filled by some other page That does not mean that page is predefined or page is reserved for that one. No, but that page will be used by any of the user, any of the program, and whenever there is a repetition or there is a back of the page, that means page in operation. So there is no specific location where the page will be stored. Now imagine how paging operation would affect our programming. That is now, uh, this is the theoretical object. That is how the paging is done, page in, page out, how the operations is done. Now imagine how the paging operations would affect our programming. This is, suppose we have a pointer pointing to some data present in a page. That is, suppose there is or there are some pointers, or we have a pointer that is pointed to some data that is present in a page. If this page gets page out, that is, if this page gets page out means go out, and it is later paged into a different physical location, then the pointer would obviously have a wrong address. This means, for example, there is a memory that contains 4 programs, right? Out of 4, the first program is phased out or transferred to the disk because there is no requirement or there is no space for the page 3 or the program 3, program 4, right? Now sudden there is a back of the pages, that is the page will be backed out. So that location is not fixed. This means the address is now changed. So whenever we perform the operations on the C language using pointers, then how it can be done? Because everything is performed on the addresses, as you know. But if there is no specific address, that is, there is no fixed address, so how operations can be done? That is a limitation. So this says, if this page gets page out and it is later paged into a different physical location, then the pointer would obviously increase the output, then the pointer would where is the point? Yeah, then the pointer would obviously have a wrong address. Hence, under Windows, the pointer never holds the physical address of any memory location. That is, we are not able to use the pointers in this under the Windows. Right? It always holds a virtual address of that location. Now, what is a virtual address? As its name suggests, it is certainly not a real address. It is a number which contains 3 parts. These parts, when used in conjunction with the CPU register, are known as the CR3. So there are 3 parts of the addresses that is known as the CR3. That is the CPU register, that is the CR3, and contents of 2 tables that is known as the page directory table and page table that leads to the actual physical address. So these are the concept. There are 2 tables, that is the page directory table and the page table that leads to the actual physical address. Now there is a page table. This is the page directory index. This is the page directory, that is the PT0, PT1, PTN. Now there is a page table, that is P0, P1, Pn. Now this is the page byte offset, that is either 0 or 1, that is the targeted page. This is the page frame that starts with 0 and ending with a number. This is the page directory register. This is the page directory register. So this is the concept, or this is the figure that shows how we are using the page directory table and how we are using the page table that leads to the actual physical address. So this is the concept. One is the page directory index, one is the page table index, one is the page byte offset, one is the page or physical memory, that is a page directory table or page directory register. The CR3 register holds the physical location of the page directory table. So this is CR3 that holds the physical location of the page directory table. So this is the page directory table. It holds the physical location where it is stored. The left part of the 32-bit virtual address holds the index into the page directory table. Which one? That is the left part, that is of 32-bit virtual address holds the index into the page directory table. So this is a page directory table that is of 32-bit one. The value present at this index is the starting address of the page table. So this is the starting address of the page table, that is the PT0. Right. The middle part of the 32-bit virtual address holds the index into the page table. So at the middle one there is a index, or there is a virtual address that holds the index of the page table. The value that is present at this index is the starting address of the physical page in the memory. That is what is the value that is available or that is present at this index is the starting address of the physical page that is available in the memory. The right part of the 32-bit, this is also a right part, that is of 32-bit, holds the byte offset from the start of the page and of the physical memory location to be accessed. This is the how we are accessing the physical memory location. Note that the CRT or CR3 register is not accessible from an application. That is, an application does not perform, or an application or CR register is not accessible from an application. Hence, an application can never directly reaches a physical address. That is, there is no communication, direct communication between the application and the addresses in the Windows. Also, as the paging activity is going on the OS, would suitably keep updating the values in the two tables. That is, there is updation of the table, or there is updating of the values in the two tables. Now, next concept is your device access. Now, this is also category of the management, or this is also category of the pointers, how we are using the pointers in the 32-bit operating system. Now, this is device access, that is how to access the devices. This is all the devices under Windows are shared amongst all the running programs. That is, every device under the Windows are shared by every program. Suppose there are 10 programs, so every device is shared by every program. So this does not mean that if program P1 is executing, that does not take, or that does not uses the Windows or uses the keyboard, mouse. No, everything is shared by every program at any point of time under the Windows. Hence, no program is permitted direct access to any of the devices. The access to a device is routed through a device that is known as the device programmer or device program. So whenever there is access to a device that is routed, or that is going, or that is transferred through a device, or through a device that is known as a driver program, which finally accesses the device. There is a standard way in which an application can communicate with the device driver. That is a way, or this is the way how we can access the device that is known as the device driver. For example, if I am using the Windows, I am saying CD player or CD driver, DVD driver, printer driver. So these are the various drivers that is used for the communication with the application. How we can communicate with the application. So it is the device driver's responsibility to ensure that multiple requests coming from different applications are handled without causing any conflict. So it is the responsibility of the device driver how to handle or how to use multiple requests from different applications. This standard way of communication is discussed in the chapter number 15 in detail. Now, next part is your DOS programming model. That is the next part. But before moving to this part, I'm going to continue this session, that is before the break, with some practical approach, because this is too boring to continue with the theory. So let's start with one practical approach, that is how to use the any program, any basic program, any tough program, anything. So let's see. Yeah, suppose I have to use the for loop, right? The nested for loop. So this is the program to illustrate how to use the nested for loop. That is important one. This is the program that shows how to use the nested for loop. Suppose I'm using this one only because this is every time it will be. Now suppose these are the two header files that I've already written, that is hash include stdi.h, hash include conio.h, right? Now there is a void main, there are two variables that is declared, one is I, one is j. So these two variables are declared. Now using the clr scr for clearing the screen, right? Now I'm using two for loop, one is outer for loop, one is inner for loop. First of all, the inner will terminate, then only the cursor moves to the outer part. This is the main consent to show what is the outer loop and what is the inner loop. For example, I am using, this is starting with int I equals to 1, then I is less than equals to 3, then I plus plus. Right, so this is the outer loop, right? If I'm using this one, this means a comment. So this will not executed by the compiler. Now this I says this is the outer loop. Right. Now for example in for loop I'm using one more loop by using the semicolon, that is for I or I take j equals to 1, j is less than equals to 2, j plus plus, for example. Again using this one. Now I have to print up the statement in the next line, that is slash n. For example, if I print I into j, that is percentage d, that is I into j, right? Or suppose I use this one, that is I into j, that is percentage d. Now uses I into j every time. Or for easiest one, I have to use, or I have to declare one more variable, that is for example k, right? So I have to use the k over here. So this is k equals to I into j, for example, and here I have to use only k. Now closes this inner loop, that is this one, first of all. Now closes this inner loop, that is this one. Now closes this loop, first of all uses get ch over here. Now uses this one over here. Now if I compile this code, there is success, there is no error. If I execute this code, this is the I into j, that is 1, I into j, that is 2, 2, 4, 3, 6. So this is the output that will print whenever we have to multiply the I into j and the I into j. Now let's see. Whenever I say let's see, that means I'm doing the dry run. Dry run means I have to implement each and every step, that this step works this one, this step works this one. So this is the main concern how it will use. So this is the inner loop. This is known as comment. For your safety or for your understanding, this is the comment. So these are the two header files that is used, that is hash include stdi.h, hash include conio.h. There is a void main, that is a main file. Now I'm declaring the variables, that is int I, j, k. So there are three variables that is declared, that is I, j and k. Right. Then there is a clear screen. Now there is a outer loop. So this is the outer for loop, and next one is a inner for loop. First of all, the I equals to 1. The condition is that I is less than equals to 3. So the condition checks, that is 1 is less than equals to 3. The condition is true. Then the cursor, whenever this condition is true, this cursor moves to the this part. So this cursor moves to the next part, that is for j equals to 1, j is less than equals to 2, j plus plus. So this is the next part that is used. So when so first of all, the condition will be checked. When the condition is okay, then go to the inner loop. Then check for this one, that is j equals to 1, j is less than equals to 2, j plus plus. Now check for this one, that is j equals to 1. Yeah, this is also okay. I is less than equals to 2, that is 1 is less than equals to 2, condition is true. Now uses I into j. The I value is 1. Why? Because every time the I value is 1. This is 1 into 1, that is the 1. So the output, the first output is your 1, right? Now comes to the next part. So this will be printed, this will be okay. Now cursor moves from this part to this part, not this part to this part. Why? Because this is the inner loop. First of all, this will terminate, that means the condition will false for this one, then only moves to the this one. So after this curly brace, the cursor again moves to this part. Now the I value remains the same because I plus plus is not incremented. The I value is same, that is a 1. But now here the j becomes 2 because this is j plus plus, this is 2, this is 1. Again check the condition, 2 is less than equals to 2. So this is equals to, so condition is true. Again going to in this one. Now the I has a value 1, the j has a value 2, that is 2 into 1 is 2. Now the output is, the k output is 2, right? The same 2. Now this will be printed. Now again my cursor moves to this part. Now j becomes 3. 3 is less than equals to 2. Condition is checked. This time the condition is not true. Why this is not true? Because 3 is not less than equals to, or 3 is not less than equals to 2. This condition is false. Whenever this condition is false, my cursor moves to the next part, that is this part, that is your outer loop. So this is the concept. That means until and unless there is till that point of time, whenever the inner loop will terminate, we do not move to the outer loop. Now the I becomes 2. Why? Because I plus plus. Now I becomes 2. This is j. Now this becomes 2. Again check the condition. 2 is less than equals to 3. Condition is true. Again moves to this part. Now this is the fresh loop. Now j value is 1. Again check the condition. True, true. Now the I becomes 2. J becomes 1. So the output is again 2. That is 2 into 1 is 2. This is the output. Now again this will not use, this will use. After this the cursor moves to this one. Now again j becomes 2. This is also true. Now I has a value 2, j has a value 2. So this is 2 into 2 is 4. Now again to go to this part. Now j becomes 3. 3 is less than equals to 2. Condition is false. Now the cursor moves to this part. Right. So in the next run, this is the 2, 1, 2, 2, 4. So we have covered about 4 terms, 1, 2, 2 and 4. Now the I becomes 3. That is 3 is less than equals to 3. The condition is true. Why? Because 3 is equals to 3. Now again go to this part. This is j becomes 1 because this is a fresh loop. Now I is a value of 3. So 3 into 1 is 3. Right. Again go to this one. Now j becomes 2. Condition is true. Now this is 3. That is 2. 3 into 2 is 6. Now There are two terms that arrives, one is 3, one is 6. Now the cursor moves to this one. Now j becomes 3, condition is false. So this will go to this one. Now I becomes 4. 4 is less than equals to 3, condition is 4. So this loop will terminate and the output will be displayed. So this is the output. One is 1, 2, 2, 4, 3, 6. This is how the outer loop and inner loop will execute. That means first of all the loop will execute, then only the inner loop will execute. Until and unless the outer loop will not inner loop will not terminate, we cannot move to the outer loop. So this is the best example for the outer and the inner loop. Now, anyone any doubt about this one? How to use this one and how to use that one? Any doubt? If then please ask from me, because this is the important concept. Yeah, hello everyone. Any doubt? Anyone? Hello. Yeah, any doubt? Anyone? Hello. Yeah, Larry and Olesam, any doubt in this program, this outer loop and inner loop program? Hello, are you able to hear me? Hello, are you able to hear me? Or yeah, any doubt? So let's take a break right now, then move to the next part, that is a DOS programming model. So let's take a break. Okay, thanks Larry. So let's take a break for 5 to 10 minutes, then come back to from the break, starting with this topic, that is DOS programming model. So let's take a break. Now let's start with the session. So come back from the break. Starting with the session, that is our next topic. What is our next topic? That is a DOS programming model. That is how we are using the MS-DOS programming model, or how we are using the programs under the MS-DOS. First of all, the full form of MS-DOS is Disk Operating System. That is, Disk Operating System is a interface that is using, or that is of CUI, that is Command User Interface. That means only we are giving the commands, not there is a drag and drop facility. Only the commands are there. We have to type the command and we have to generate the output. That is the main concern, or that is the concern why we are using this one, right? So this is typical 16-bit environment like DOS uses a sequential programming model. Typical 16-bit means because DOS is of 16-bit environment, that is they are using, or in DOS 16-bit is used. That is a 16-bit environment like DOS use a sequential programming model. In this model, programs are executed from top to bottom in an ordinary or orderly fashion. That is, in this 16-bit environment, in DOS environment, the program will execute, or program executes from top to the bottom in an ordinary or orderly fashion. That is, from bottom to top or top to bottom in a proper manner or sequential manner. The path along which the control flows from start to end may vary during each execution. That is, the path which is followed from the starting to the ending phase may depend on the input, may depend on the output, may depend on the input devices. So the path is vary from condition to condition, where each execution depends on the input that the program receives or the condition under which it can run. However, the path remains fairly predictable. C programs written in this model begin execution with main function. That is, the C programmer, whatever is given, that program will begin with the main function. As I told you, in C program, void main is like a main entry gate. that is the main starting phase. So execution of the program begins with the main function, that is known as the entry point, as I said, and then call other functions present in the program. Suppose I am using one for loop, that is also a type of function, not a function, that is a loop. But suppose I have declared one function, that is calculation. So first of all we are entering into the main gate, that is the main function, then uses another function, that is other functions also, for comparison purpose or for calling purpose or ending purpose. In this programming model, it is a program and not the operating system that determines which function gets called and when. That is, or this is a model that determines which function we are using, uh, or it is a program, not the operating system, that determines which function we are using and when and why. What is the main reason? The operating system simply loads and executes the program and then waits for the finish. So it is the responsibility of the program to execute the code, not the responsibility of the operating system. Their operating system is just like a coordinator, only coordinate the things, executes the things, wait for the program to finish. If the program wishes, it can help of the operating system to carry out jobs like console input output, file input output, printing, etc. That is, it, if they so, they can use these facilities like console input output, file input output, printing, etc. For other operations like graphics, carrying out special communication, the program has to call another function, another set of functions, that is known as the ROM BIOS function. Now, what is the full form of ROM BIOS function? That is a read-only memory, and then BIOS means basic input output system. Unfortunately, the DOS functions and the BIOS function do not have any names. That is the DOS function that is given, and the BIOS function, that is the basic input output functions, do not have any names that is given. Hence, to call them, the program has to use a mechanism known as interrupt. That is, the DOS functions and the BIOS functions do not have any names, so to call them, to use them, the program has to use a mechanism that is known as the interrupt. So interrupt is a program that is used as a program for the DOS function and the BIOS function. This is a messy affair since the programmer has to remember interrupt numbers for calling different functions. Moreover, communication with these functions has to be done with CPU registers. So it is the responsibility of the CPU registers to deal with this one, that is how to use these functions and how to done the communication with these functions. This leads a lot of difficulties since different functions uses different register for communication. That becomes a hodgepodge condition. Why? Because if I'm using one function and you are using one function, so there are multiple registers, there are multiple demands, there are multiple supplies, there are multiple interrupts that is given in the CPU register. So this leads to a difficulties, programming, confusion, conflict among different programmers, functions. So it is not suitable for the communication. To an extent, these difficulties are reduced by providing library function that in turn known as the DOS BIOS functions using interrupt. But the library does not have a parallel mechanism for every DOS BIOS functions. DOS functions either call BIOS functions or directly access the hardware. That is, whenever we have to use the function, that is a DOS function, they either call the BIOS function, that is the basic input output function, or directly access the hardware, that is the directly accessing the hardware. At times, the programs are needed to directly interact with the hardware. This has to be done because either there are no DOS BIOS function to do this, or if they are their reach is limited. Figure 14.2 captures the essence of DOS programming model. So this is the figure that shows how to use the DOS programming model. So there is one execution, there is two execution, there is an interrupt, CPU, register. There are multiple concepts. So let's see. This is the main function. This is the fun. This is the curly braces. Now this function will be called. Now this function will be used, that is declare. this is the definition. So these are multiple parts. So first of all, whenever it is using the DOS operating system, on execution, control transfer to the program. That is, whenever it executes, the full control transfer to this program. The full control is going to this program. Right? Now, next is your DOS function. So these are the DOS functions. This is the fun function. This is the definition of the function. There is an interrupt and CPU registers. This is also interrupt and the CPU registers. There is a BIOS function. This is the BIOS function. This is the hardware. Next is your hardware. So these are the various definitions, various functions, various DOS functions, BIOS function, hardware that is used. That is the definition of the fun. Right. This is sequentially executing DOS program. From the above discussion, you can get that there are several limitations in the DOS programming model. That is, there are so many drawbacks in this example, in this diagram. There are so many limitations that is available in the DOS programming model. Now, let's see what are the limitations. No true reuse. That is, a library function that is used that are called from each program become part of the exe for that program. Therefore, the same function get replicated in several exe files. That is, the same function will be reused again and again in the form of exe file, thereby wasting the precious disk space. So it takes the more space, so it wastes the precious disk space so that it can be used again and again anywhere. So these are the various limitations. Now, what is the next limitation? The next limitation is inconsistent look and feel. That is, every DOS program has a different user interface that the user needs. That is, every DOS program has a different user interface that the user has to get used to before he or she can start getting work out of the program. So every DOS program have a different interface that the user uses for the getting work out of the program. For example, successful DOS operating based software like Lotus 123, Fox Pro, WordStar offer different types of menus. This happened because DOS BIOS does not provide any functions for creating user interface elements like menus. As the look and feel of all DOS-based system is different, the user takes a lot of time in learning how to interact with the program. Now, the next limitation is that there is a messy, that is, there is a hodgepodge calling mechanism. Whenever we use the DOS operating system, there is a hodgepodge calling mechanism. That is, there is no one line, or there is no sequence in which one program is one function is calling another function, another function is calling another function. No, but there is a messing, or that is a messy calling mechanism. That is, there is a hodgepodge calling mechanism. One program, one function calls to another program, another function calls to third program, and so on. It is difficult to remember interrupt number and the registers that are to be used for communication with DOS BIOS function. So it is very difficult to remember the interrupt number that is available and the registers that are to be used for communication with the DOS BIOS function. That is, it is not in the mind of everyone that is used, or that how it will be used. For example, if we are to position the cursor on the screen using a BIOS function, we are required to remember the following details. That is, there is a different, or there is a messy mechanism, calling mechanism. So we have to remember each and everything whenever we have to use the DOS BIOS function. Like in this example, there is a different interrupt number. There is a different CPU register that is to be used. There is AH2, DH, that is a row number, position number, column number, where the cursor position is to be positioned. While using these interrupt numbers and registers, there is also a chance of error. So there is a chance of error. This is also a limitation of using this one. Now, Next part is hardware dependency. Can anyone from both of you can explain what is hardware dependency in terms of anything? Means if a term arises, hardware dependency, what is the meaning of this? Larry and Olesa, my question is to both of you. Anyone can answer. What is hardware dependency from your point of view? My question is to both of you. Anyone can answer. What is hardware dependency? Hello? The next term is hardware dependency. So anyone can tell me what is hardware dependency? My question is to both of you, Larry and Olesam. Can you tell me in any terms what is hardware dependency according to you? Yeah, are you able to hear me? Hello? Hello, 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 hello. Yeah, are you able to hear me? My question is to both of you, what is hardware dependency? Yeah, can you tell me, you are Larry? Yeah, can you tell me what is hardware dependency according to you? Okay, can you tell me what is pardon? Yeah, sure. Yeah, yeah, sure. Yeah, yes. Yeah. Mhm, mhm. Yes, yes. Good, good, good. Okay, okay, all right, good. So this is the correct. Hardware dependency means every program is dependent on the hardware. That is, those programs are always required to bother about the detail of the hardware on which they are running. This means they are bother or they are required to bother means they have to take care or they are dependent on the hardware on which they are running. For example, those programs are running on a keyboard, mouse, printer. So those programs are always required to bother about the details of the hardware on which they are running. This is because for every new piece of hardware introduced, there are few interrupt or there are new interrupt number and new register details. So every time new hardware is introduced, so that can be introduced by using the or there are new interrupt number, new register detail. Everything is new. Everything is coming up newly. That is a new interrupt number, new register details. Hence, those programmers are under the constant fear that if the hardware on which the programs are running changes, then the program may crash. That is, the, those programmers have a fear that if the programs or if the hardware on which the programs are running changes, then the programs are failed. Why? Because if I'm using one hardware and at the same time if I'm using another hardware, so the program may be different or the program may be or the running program may be different. So that will affect on the program to program. So it depends on the program to program. There is a fear that if the hardware on which the programs are running changes, then the program may crash. This is also the limitation of the DOS operating system of the DOS programming model. One is hardware dependency, one is messy calling mechanism, inconsistent look and feel, because there is a black offline that one. Now, moreover, the DOS programmer have to write a lot of code to detect the hardware on which his program is running. That is, they are not easily able to get on which hardware they are running, but they have to write the code for this one. That is, they have to write the code for detecting or for using or for detecting which hardware is running, or which program or which program is running, and suitably make use of the relevant interrupted registers. Not only does this make the program lengthy, the programmer has to understand a lot of technical details of the hardware. That is, every programmer has to take care of every detail of the program, how it will be running and how it will be executing. Not only does this make the program lengthy, but they have to aware of the technical details. As a result, the programmer has to spend more time in understanding the hardware than in the actual application programming. This is the concept that shows there are so many limitations in the DOS operating system, DOS based programming model. One is inconsistent look and feel. Next one is your hardware problems, hardware dependency. There is a messy calling mechanism. So these are the various limitations that is available in the DOS programming model. Now, the next part is Windows programming model. So till now we have covered basic or the DOS programming model, limitations of the DOS programming model. The next part is your Windows programming model. So this is a new concept. Larry, can I start in the today's class, or can I start in the tomorrow's class? If you think this is too heavy, because there are so many theory work that is to be done. So it's your advice. If you tell me that I will continue, otherwise I will continue in the next class. So tell me, Larry and Olesam, can I continue in the today's class, or can I continue in the next class? If this is not over to you, that is DOS programming model, so I continue this one. Otherwise I have to continue, or I will continue in the next class. So tell me, anyone, if I continue this one or not. Next class. So okay, Larry, thanks for answering. So let's take one simple program for practical approach. This is okay, or shall I finish this class right now, or shall I go to the only one program? I think some time are left. So either we can do a practical approach for one program, or either I can stop the class. It's your choice, not my choice. Okay, so let's take a practical approach. This is the program for the smallest, and this I have told you earlier. Now, now let's see how to find the average of a number of two numbers without using any array variable. Till now we have covered how to find the average by using the array variable. Now I'm going to continue with the program, that is how to use the, or how to find the average out of the three given numbers. Right. So these are the three given numbers. One is the concept that is known as the average. For example, this is the concept. This is the average. So there are three numbers. We have to scan these three numbers. Now, finding the average for this one. So enter three numbers. This is the same program or the continuation of the program, that is hash include stdi.h conio.h. There is a void main. There is a four variable that is declared. One is a, b, c. One is average. The average is in float. So this is float average, right? This is semicolon over here. Now there is a clear screen for clearing the screen. Now there is a printf statement, that is enter the three numbers. That is the enter three number, that is the input taken by the user. Now scan this one by using the ampersand. This is ampersand a, ampersand b, ampersand c. Now I have to find the average. For average, first of all I have to use the sum. So there is one more variable, that is the sum. So this is sum equals to a plus b plus c, right? Now I have to find the average, that is equals to sum divided by 3. There is a semicolon. If I execute this code, there is a warning. What is a warning? Average is assigned a value that is never used. That is, this is assigned a value. Now if I execute this code, enter the three numbers. If I enter 12, 12, 12, where is the output? Output I have not displayed. This is the error. Now I'm using printf. The average of three numbers is percentage f, then uses the variable, that is average, then semicolon. Now if I compile this code, if I enter this one, so the average is 12.000. Again if I compile this code, this is 11, this is 13, this is 43. So the average is this one. Right. If I again compile this code, this is 2, this is 6, this is 5. The average is 4.000. So this is the average, how we can calculate the average without using any variable, without using any array. So this is the way how the average will be finding out. So Larry, this concept is clear, how to find out the average? Now this C, this is the turbo C. These are the various menus. This is the file menu, this is the edit menu, search, run, compile. We can also compile from this one. We can also execute it for this one. Right. So this is the key for the compilation, that is Alt F9. This is the key for the execution, that is the Control F9. There is a debugging, there is a project, options for compilation. There is a window, that is either you can move, size, see the output like this one. So this is the output screen as well as this one at the same time. This is the user screen. If you want to go to the output, so these are the various options that is available over here. Now I don't know what is the usage of this one. if I want to save, simply saved it by the name, that is the average, right? This is the quitting purpose, that is the alt X is used for the quitting purpose. So that's all for today's session. So that's all for today's session. Thank you so much everyone for listening me. In the tomorrow's class I will be starting with your next topic, that is Windows programming model. So thanks a lot everyone for listening me. Bye bye.